Welcome to C002. In our last lesson we learned about the mole, the chemist's counting unit. Now we are going to put it to work. Stoichiometry is the study of the quantitative relationships between reactants and products in a chemical reaction. In simple terms, it answers the question, if I start with this many grams of these chemicals, how much product will I get? This is the heart of practical chemistry, and it is heavily tested in NET. Let us build it up step by step. Before we get into the maths, let me give you an analogy that makes this whole topic click. Think about cooking. Imagine a recipe for one omelette requires 2 eggs and 1 onion. You have 10 eggs and 3 onions. How many omelettes can you make? You might think 5, because you have 10 eggs. But note you only have 3 onions, and each omelette needs 1 onion. So you can only make 3 omelettes. The onions run out first. The onions are your limiting ingredient. You have 4 leftover eggs, those are your excess. Chemistry works exactly like this. The balanced equation is the recipe. It tells you the exact ratio in which reactants combine. The limiting reagent is whichever reactant runs out first. And it is the limiting reagent, not the excess reagent, that determines how much product you get. This one idea is the entire basis of stoichiometry. Every stoichiometry problem starts with a balanced chemical equation. Why must it be balanced? Because of the law of conservation of mass, atoms cannot be created or destroyed in a chemical reaction. The same number of each type of atom must appear on both sides of the equation. Let me show you how to balance the combustion of methane. We start with CH4 plus O2 gives CO2 plus H2O. Carbon is already balanced, 1 on each side. But hydrogen is not, we have 4 on the left and only 2 on the right. So we put a 2 in front of H2O. Now hydrogen balances, 4 equals 4. But now oxygen is off, 2 on the left, 4 on the right. So we put a 2 in front of O2. Now everything balances. The golden rule, only adjust coefficients, the large numbers in front. Never change the subscripts inside a formula, because that would change the substance entirely. Once an equation is balanced, the coefficients give you the mole ratio, the exact proportions in which the substances react and are produced. Take the Haber process, nitrogen plus 3 hydrogen gives 2 ammonia. The coefficients 1, 3, and 2 tell you that 1 mole of nitrogen reacts with exactly 3 moles of hydrogen to produce 2 moles of ammonia. These ratios scale perfectly. If you use 2 moles of nitrogen, you need 6 moles of hydrogen and you get 4 moles of ammonia. You can also convert to grams. Nitrogen has molar mass 28 grams per mole. Hydrogen is 2 grams per mole, so 3 moles is 6 grams. Ammonia is 17 grams per mole, so 2 moles is 34 grams. Notice that 28 plus 6 equals 34 mass is perfectly conserved. This is the core skill of stoichiometry, use the mole ratio from the balanced equation to convert between any substances in the reaction. Now let us learn how to identify the limiting reagents systematically. There are 3 steps. Step 1, convert all given masses to moles. Take each reactant mass and divide by its molar mass. Step 2, for each reactant, divide its number of moles by the coefficient it has in the balanced equation. This normalizes each reactant to the scale of the reaction. Step 3, whichever reactant gives the smaller number in step 2 is the limiting reagent. It runs out first. Here is the most important rule to remember: once you identify the limiting reagent, you must calculate the amount of product using only the limiting reagent. Never use the excess reagent to calculate yield. The excess reagent has leftover material that does not react, so using it would give you a higher, incorrect answer. The limiting reagent controls everything. Let us solve a complete example. We have 28 grams of N2 reacting with 9 grams of H2 in the reaction. N2 plus 3H2 gives 2NH3. Step 1, convert to moles. Moles of N2 equals 28 divided by 28, which is 1 mole. Moles of H2 equals 9 divided by 2, which is 4.5 moles. Step 2, divide by coefficients. For N2, 1 mole divided by coefficient 1 equals 1.0. For H2, 4.5 moles divided by coefficient 3 equals 1.5. Step 3, N2 gives the smaller value of 1.0, so N2 is the limiting reagent. Now calculate product from N2 only. The equation says 1 mole of N2 produces 2 moles of NH3. 2 moles of NH3 has mass 2 times 17, which is 34 grams. For the excess, the reaction needs 1 times 3 equals 3 moles of H2. We had 4.5 moles, so 1.5 moles of H2 is left over. That is 1.5 times 2 equals 3 grams of excess hydrogen. Practice this 3-step method until it is automatic. Here are your focused NET tips for stoichiometry. The most common question type gives you masses of 2 reactants and asks either how much product forms or how much of one reactant is left over. Follow the 3-step method every time: moles, divide by coefficient, compare. NET also occasionally tests percentage yield. The formula is actual yield divided by theoretical yield, multiplied by 100. The theoretical yield is what you calculate from the limiting reagent. The actual yield is what you get in reality, which is always less due to side reactions, spills, and incomplete reactions. A quick self-check after balancing any equation: add up the molar masses of all reactants and compare to all products. They must be equal. If they are not, your equation is not balanced correctly. And the most dangerous mistake: students often calculate product from whichever reactant they see first, rather than identifying the limiting reagent. Always find the limiting reagent first. Excellent work. Let us review. Stoichiometry is the study of quantitative relationships in chemical reactions. Every stoichiometry problem starts with a balanced equation, and you balance by adjusting coefficients only, never subscripts. The coefficients give you the mole ratio, the exact proportions in which substances react and are produced. When 2 reactants are given, you must find the limiting reagent using the 3-step method: convert to moles, divide each by its coefficient, and the one with the smaller result is the limiting reagent. Always calculate your product from the limiting reagent. In the next lesson, C003, we move to atomic structure and quantum numbers, the deep dive into what atoms are actually made of and how electrons arrange themselves. That is where modern chemistry really begins.